So very good morning to all of you. We have solved the example of column and member of truss using single angle section. Okay, and by using the empirical equation as well as how to find out the FCD by using the table from IS code that also we have seen in previous class. Okay, so today we will solve one example uh, for the strut or using a double angle section design of your uh, member of your truss. Okay, so this one uh, write down this example. Design a double angle section back to back on each side of gusset plate of thickness 8 mm for continuous principal rafter for continuous principal rafter for continuous principal rafter to carry a factored load of 250 kilonewton to carry a factored load of 250 kilonewton 250 kilonewton. The center to center distance of the member is 2.5 meter. 2.5 meter. So this example, we will solve the example. Today our lecture number 25. So the subject is design of steel structure. Subject code is 301003 and today is 4th of September 21. Okay, so design out member of truss in compression. So what is given in our example, we will write down first that the length of member is given 2.5 meter and the factor axial load of 250 km. Also the gusset plate thickness is given 8 mm. We will write down data given for design. What is given? The unsupported length is given 2.5 meter. The factored axial load PU is given. Factored load is given 250 kilonewton and thickness of gusset plate is given. Thickness of gusset plate is given. Thickness of gusset plate is equal to is given 8 mm. So this is given, data is given, and design of member of truss in compression using double angle section. Double section. So this is a problem which is given in this example. We are going to solve, design a double angle section. स्टार्टिंग में ही लिखा है कि डिजाइन है डबल एंगल सेक्शन बैक टू बैक ऑन ईच साइड ऑफ द सेट प्लेट. Thickness of the set plate is given 8 mm for a continuous principal rafter. Rafter in gravity and generally it is a compression member to carry a factored load of 250 kN and the center to center length of the member is 2.5 meter. Okay, so all this data is given. We will assume Fy is 250 Newton per mm square. Yield stress of the member. Also Fe 410 will consider for ultimate strength. So these are given, and what we have to design, we have to select a section such that double angle section such that the angle section will capable of taking a load of 250 kN. So which type of angle section they are dealing with? The double angle section back to back. Double angle section back to back. Thickness of the set plate it is 8 mm. Angle section still we don't know. We have to choose. We have to select double angle section. So I will write it 2 ISA dash still we don't know. Okay, as I start. So this step number 1 is generally we are finding out the effective length. We are finding out the effective length of member. That is called as LE. So LE is equal to K times L. K for double angle section we have to know from our previous lecture notes. Is my screen is visible to you? Just I am saying visible, huh? Okay. So this how to find out effective length of this you can see from here. I will open the previous notes of the compression member where the effective length is given, and we already discussed lots of about the effective length. This effective length is for column. Now here we have the member of truss. We don't have the member of the column. Okay. So for effective length of column you have to use the table number 11 of IS code, but for effective length of this strut or compression member you have to select from this table. This table already we have discussed. You can make this table in your notebook also. Okay, so here the continuous member is there and double angle section is there. So you have to choose the effective length from 0.7 L to 1 L. 0.7 L to 1 L. So I removed one person from the meeting because he is unmuted. So that is disturbing the class. Anyone who will disturbing the class, I will remove him from the class. Then he is not able to join the class on the same day. Okay, so don't do that. So this here continuous member is there, and our in case of double angle section or single angle section, the effective length will be 0.7 to 1 L. Because this is continuous, if this is discontinuous, then because it is perpendicular So gusset, it is a plane of gusset. If continuous member is there, definitely it is in the plane of gusset. So we will choose the effective length between 0.7 to 1 am. आप 0.7 भी ले सकते हैं, आप 1 भी ले सकते हैं, in between भी आप ले सकते हैं. So we'll take here the k value will take here uh, 0.85 in between 0.7 to 1 L. So in between this k value 0.7 to 1, we have chosen 0.85 into L is 2500 mm. So it will give us the effective length of our section. It will give us the effective length of section. So if you find out the effective length, so 2500 into 0.85, it is around 2125 mm is the effective length of our this continuous double angle section. Now in step number 2, because we don't know the section, we know the load, so we can assume the FCD. Assume FCD for फर्स्ट ट्रायल. पहला ट्रायल के लिए हम क्या करेंगे, एसपीजीए. तो मैंने आपको पहले भी बताया कि अगर आपका मेंबर ऑफ रूट ट्रस है तो एफसीडी जो अज्यूम करेंगे, कंप्रेशन मेंबर ऑफ रूट ट्रस अगर है, ट्रस और ब्रेसिंग है, एससीडी यू विल अज्यूम इन बिटवीन 80 MPa to 120 MPa. Okay, but if column is there, then FCD we will assume from 120 to 180 MPa. So here in our case it is the compression member of root truss, so we will go for 80 to 120 MPa. So I will assume my FCD here, take for calculation, take for trial 1, FCD is equal to 120 MPa or 120 Newton per meter square. 120 Newton per meter square. Okay, so this is the assumed FCD. Now in step number 3, you have to find out the area required to select the section. The area required you can find out because the load is given 250 into 10 raised to 3 Newton. It is 250 kilonewton, means 250 into 10 raised to 3 Newton divided by assumed FCD, it is 120. The area required for our section is 250 into 10 raised to 3 divided by 120. The area required for our angle section is 283.2083.33 mm square. So this area we required. So because we are using double angle, because or since we are using double angle back to back, then area of single angle will be 2083.33 divided by 2. So area required for single angle is 1041.66. mm². Now this step number 1, we have find out the LE. It is 2125 mm², as per we have selected the effective length. Then assume FCD in between for the member of truss 80 to 120 MPa, so we are considered 120 MPa. And based on that, because we know the load, we can find out the area required. Because this is double angle section, the strength of single angle we will find out first, and then we will multiply. So area of single angle is 1041.67 mm². Okay. Now step number 4. Step number 4. What is step number 4? Select section. Selected section. So selection of section is based on the area. In case of compression member, it is based on area. So area required is for single angle 1041.67. Area we will choose such that it should be greater than 1041. Should be greater than 1041. So what we will do here? We will go for IS 808 or steel table. Okay. तो IS 808 में इक्वल एंगल सेक्शन अगर हम सेलेक्ट करते हैं तो विल सी हियर द एरिया. तो हियर यू कैन से द डिजिग्नेशन ऑफ एंगल सेक्शन, मास kg per meter is second column, third column is the cross section area. So this cross section area you have to compare, you have to see. So in our case, this area required is 1041 mm². If you will convert in centimeter square, this area is given here centimeter square. So 10.42 centimeter square is the area required. This is the area required. We will compare this with this 10.41 से ज़्यादा कहाँ पर है? ये 10.6 सेंटीमीटर स्क्वायर. कॉलम नंबर 3 में आप देखिए यहाँ एरिया दिया हुआ है. तो अगर मैं ISA 60/10 में जाता हूँ तो इट इज 1100 है ना, 1100. तो हम लोग ये सेक्शन चूज कर सकते हैं. तो अगर मैं यहाँ पर लिखूँ ISA 60/10 और इसका वेट क्या है, इसका वेट भी दिया है स्टील टेबल में. वेट क्या है 60/10 का 8.6 kg per meter. 8.6 kg per meter. So I will write the weight of this section 8.6 kg per meter. सेकंड हम कौन सा सेक्शन ले सकते हैं और हम देखते हैं तो यहाँ पर 10.6 ISA 70/8. ISA 70/8 is the area is ISA 70/8. area is इसका एरिया कितना था हमारा 1100 mm². इसका एरिया है 1060 mm². ओके. वेट कितना है, दिस इज द वेट आल्सो. तो इसका वेट है ISA 70/8 का वेट है 8.3 kg per meter. 8.3 kg per meter. नाउ ISA और सेक्शन देख सकते हैं हम लोग. ISA 75/8 का 11.4. यहाँ पर ISA 75/8. the area is 1140 mm². Okay. और इसका वेट क्या है वो देखेंगे। वेट है ISA 75/75/8 का वेट है 8.9 kg, 8.9 kg पर मीटर। तो आई विल राइट हियर 8.9 kg per meter. So here you can any one of these member you can select and design. Okay. So here I say 60/60/10. Okay. You can choose this one. The area, all this members area is greater than 1041. Okay. So any one of the section you can choose, all is choosable. But if you see the weight here, weight per kg, so you can see this, this is seem to be economical. But area is too close. The area is too close, maybe it will not be safe. Okay? And then another one is this one, I say 60/60/10. Thickness is larger than the cassette plate. It is okay, we can go for this also. Or you can go for the 75/75/8, but the weight is large. Okay, तो यहाँ पर weight आपका ज़्यादा है, so it may be the uneconomical section. But you have to think over that the area is good here. It is much difference with the 1040, yani around 100 mm is large. So maybe this will be safe for us. So either you select this ISA 60/60/10 or either 70/75/8 mm. This one also you can select, but here the area is too close, it may fail. It may fail, you have to check. That is the trial and error method design. So we will select from this, select, select two ISA, two ISA 60/60/10, है ना, 60/60/10 mm for our case. Okay, so now you have to write down step number, this is step number 4, I think so, 3, 4. Step number 5, step number 5, properties of, properties of chosen section, chosen or selected section, that is ISA 60/60/10. So what is the properties? Properties, generally we require radius of gyration to know the slenderness ratio. Okay, so if you come here, so ISA 60/60/10, this one, the radius of gyration is given in RXX and this 14 and 15. I will come here. So 60/60/10. This radius of gyration is, radius of gyration is 19.4 mm 4. Okay. So RX6 or YY both are 19.4 mm. Sorry, 16.8 mm. I will write down R minimum RX6 is nothing but RZZ 17.8 mm. RYY for single angle it is 17.8 mm. Okay. RUU, RUU of the section. RUU, RU, RY. 22.3 and 11.5 RGB. 22.3 RGB is 11 point. It is seems to be minimum. It is seems to be minimum. But here we are going for double angle section back to back. अगर हम डबल एंगल सेक्शन बैक टू बैक जा रहे हैं, दिस इज आवर डबल एंगल सेक्शन बैक टू बैक. So this our axis YY, is our axis ZZ. So about major axis RZZ is 70.8 mm. But RYY you have to find out. RYY you have to find out because double angle section is here. This is the CPO, triangle section. So this CYY. CYY. So you have to convert this moment of inertia, and then you have to find out the various this lambda. R minimum, RYY. So how you can find out RYY? So RYY you can find out because this is double angle section. Then this we will not consider. Single angle section we consider, but double angle section because this strengthen the section by using the double angle section and placing a part. Okay. So here if I will find out the IYY value, so RYY we have to find out, that is nothing but radius of gyration is nothing but I upon A. तो IYY हमको मालूम करना पड़ेगा. Okay, IYY is equal to about YY axis equal to IYY plus A into H square. H is nothing but this distance from this CG. There is different. So using parallel axis theorem, you have to find out the centroid of moment of inertia about this YY axis. Because this YY axis for the two sections, they are not coinciding with the CG of the whole section. तो CG of the whole section के लिए हमको ये मालूम करना पड़ेगा. CG of the whole section के लिए हमको मालूम करना पड़ेगा IYY. तो IYY about its own axis plus area into square of its distance is nothing but parallel axis theorem. So IYY it is given into our I scope. So IYY here centimeter cube raised to 4 में दिया हो. It is here 34.8 centimeter raised to 4. I will write down this for 10 IYY here this column 34.8 centimeter raised to 4. So IYY it is given 34.8 centimeter raised to 4. So raised to 4 is there. This is centimeter. Mm में it will be 10 raised to 4. The mm में centimeter का convert करेंगे. So it will be converted into mm raised to 4. Okay. Because in steel table it is given I is given 34.8 centimeter raised to 4. When we convert it into mm, 34.8 into 10 raised to 4 mm raised to 4. So that's why here written plus area of the section. Area of section is 1100. So I will write out 1100 into h is nothing but the distance between the CG of this. So the CG of the plate will be each side. This is 4 mm. 4 mm. H will be what the value of h is equal to 4 mm, that is 8 by 2 plus cx6. This distance is cx6. Okay. So I will take the cx6 value. Here it is given cx6 value. Here cx6 in column number 8. So we will come here, and this is 18.5 mm. I will write here. This is 18.5 mm. So 4 mm plus 18.5 is, it is 22.5 mm. I will write down 22.5 whole square. Okay. Now this is for single angle, because it is double angle into 2. Okay. So I will write down double angle into 2. So 22.5 square is 506.25 into 1100. So it is 34.8 into 10 raised to 4 plus 55.68 into 10 raised to 4 into 2. So plus 34.8 plus 55.68 into 10 raised to 4 into 2. So it is coming around 180.97 into 10 raised to 4 mm raised to 4. Now area of single angle is 1100. तो एरिया का भी हम डबल करेंगे, तो इट विल बी, I will find out the RZZ or YY is equal to under root of I minimum IYY upon R area. तो एरिया हमको मालूम है, आई हम लोग को मालूम है 180.97 into 10 raised to 4 divided by area equal to, so 180.97 into 10 raised to 4 divided by area is coming under root of 822.6. Under root of 822.6, we will find out is coming 28.68 mm. तो RZZ हमारा कितना है? RZZ is 17.8 something, 17.8 mm. RZZ is 17.8 mm. So this is less than this 28.68. So that's why always when we are going for the double angle section back to back, RZZ will be minimum, because you are putting the angle at the distance, RY will be greater. So that's why the R minimum, this will be the R minimum. Okay. So we will take R minimum. Then what is the slenderness ratio? Lambda is equal to K into L upon R minimum. K is 0.85. Unsupported length is 2500. We already calculated 2125 is coming, and R minimum 17.8. For single angle we are considering. So we will find out this 2125 divided by 17.8, then it is 119.38. The value of lambda is coming 115.0. Okay, so lambda is 119.38. This is the slenderness ratio for the section. Now we have to find out the FCD. The FCD you can find out by the empirical equation or by the FCD empirical equation से अगर हम लोग जाते हैं तो it is given that FCD is equal to stress reduction factor x into Fy upon gamma m0 and x की वैल्यू क्या है? Stress reduction factor it is nothing but 1 upon it is 1 upon, now I score it is given, go to the page number, sorry, here you can see x is nothing but the stress reduction factor, it is nothing but 1 upon 5 plus under root of 5 square minus lambda square. So here we have to do the reverse calculation. First we have to find out the lambda e, and then first you have to find out FCC, and from FCC you can find out the lambda e value. So lambda e is non-dimensional effective slenderness ratio. So first we have to find out lambda e, non-dimensional effective slenderness ratio. Effective slenderness ratio. So lambda is equal to under root of Fy upon FCC. Now what is the FCC? Is nothing but pi square E upon KL by R square. So pi square into E is 2 into 10 raised to 5 for steel, and this is, we have just find out the lambda value, that is 119.38. Why we write on 119.38 square. Okay, 119.38 square. Okay, so pi square into 2 into 10 raised to 5 divided by 119.38 square. So it is coming, FCC is coming 138, FCC is coming 138.505. Okay, if I will write this value in lambda e is equal to under root of Fy is 250 divided by 138.505. 250 divided by 138.505. So lambda e is 1.8 under root of 1.8 under root of 1.8 will be 1.34. So lambda e will be 1.34. Now we know the lambda e, you can easily find out the phi value. Phi is equal to 0.5 in bracket 1 plus alpha lambda e minus 0.2 in plus lambda e square. Now here you have to find out the buckling class of section. So any angle कोई भी एंगल है तो इसका बकलिंग क्लास क्या होता है? बकलिंग क्लास इज सी क्लास. तो अल्फा इज इक्वल टू पेज नंबर टेबल नंबर 7 में अगर रहिए फॉर सी क्लास अल्फा इज 0.49. So here you can write down alpha is equal to 0.49 for बकलिंग क्लास सी. बकलिंग क्लास कहाँ से मालूम करते हैं हम लोग? बकलिंग क्लास हम लोग टेबल नंबर 10 से मालूम करते हैं, ये तो मैं पहले बता चुका हूँ आपको. टेबल नंबर 10 जो दिया हुआ है कोड में, वहाँ से हम लोग इस टेबल, ये टेबल जो टेबल नंबर 10 दिया हुआ है, यहाँ से हम बकलिंग क्लास मालूम करते हैं. एंगल सेक्शन, कैनल सेक्शन, टी सेक्शन और सॉलिड बार और सर्कुलर और रेक्टेंगल, एनी टाइप ऑफ एक्सिस द बकलिंग क्लास विल बी सी, है ना. तो उससे हमको ये मालूम हो गया. नाउ वी पुट द वैल्यू, वी नो द phi is equal to 0.5, 1 plus alpha is 0.49, lambda is 1.343 minus 0.2 plus 1.343 square, will get the value of phi. So phi is equal to 1.343 minus 0.2 into 0.49 plus 1 plus 1.343 square into 0.5. So this gives you the alpha value, the phi value is 1.68. The value of phi is 1.68. Now, what is x? X is the stress reduction factor. It is 1 upon phi square plus under root of phi square minus lambda e square. Lambda e square. Okay. So this we can put the formula. Values phi is 1.68 square plus under root of phi 1.68 square minus, this is not square, phi plus, I think so. This is phi plus, okay, 1.34 square. So stress reduction factor x is equal to, or psi is equal to 1 upon phi is 1.68 square plus 1.68 square minus 1.34 square under root of that is 1 point something plus 1.68. Here there is no square, only in brackets. So it is coming 1.016 plus 1.68, sorry, plus, sir, it is 2.69, 1 upon 2.69. सर इनवर्स अगर हम करेंगे तो टू द इनवर्स, तो 1 upon 2.69 का इनवर्स 0.37. तो FCD is equal to stress reduction factor into Fy upon gamma m0. So 0.37 into 250, gamma m0 is 1.1. So into 250 divided by 1.1, the FCD is coming 84.48 Newton per mm square. Okay. Now we will design a section. We will section classification. If section is plastic or compact or semi-compact, then A is equal to 80. That's why we need a section classification. It may be the step number 6, I think so. So if you write here P by T or D by T value, so 60 by 10 is equal to 6, okay, which is less than 9.4, sorry, 15.7 epsilon, which is less than 15.7 epsilon, is the plastic. Section is plastic. B plus D by T, B plus D by T, and 60 plus 60 by plus T, it is equal to 12, which is less than 25 epsilon. So here it is not plastic. The angle section is always in semi-compact limit. There is no plastic or compact limit. These are both are the semi-compact limit. Semi-compact. So in this case of angle section, we will say that A is equal to AG, and that is 1100 mm square for single angle. Okay, so PD is equal to FCD into AE. FCD हमारा कितना आया? FCD is how much? You have calculated 84.48. So I will write down 84.48 into AE is 1100 for single angle. Okay, for single angle. So it is coming 92.94 into 10 raised to 3 Newton, or you can say that 92.94 kilonewton single angle. But double angle के लिए 2 times this angle back to back into 2 अगर हम करेंगे तो it is coming 185.87 kilonewton, which is less than 250 kilonewton. इसका मतलब क्या हो गया? It is not okay. So our PD is less than PU. PD is less than PU. It means that the ISA, 2 ISA 60 by 10, it is not capable of taking 250 kilonewton load compressive load. Now this section fails to ISA 60 by 10. Now we will go for trial number 2. Select section 2 ISA 75 by 8. तो इससे आपको वापस से रिकैलकुलेशन करना पड़ेगा, और जब आप इससे रिकैलकुलेशन करेंगे तो योर पीडी विल बी 270 kilonewton. So PD will come 270 kilonewton, and this is greater than 250 kilonewton. So you have to make calculation for trial 2 so that the section will be. So here your section failed. When section failed, so doesn't bother about that. Section fail हो गया, इसका मतलब नहीं कि हमने गलत किया है. Again you have to say another section, this one, and recalculate all this what you have done the steps, and recalculate, and then check the value. If the PD is greater than PU, then you can say that our design is okay. But here in our case, your design, but I say 60 by 10 is fails. Okay, so that's why it depends on the radius of gyration, member sectional properties for design of your compression member. So selection of section is such that it doesn't fail, but it will come आपको कब आएगा? एक्सपीरियंस आएगा। कैसे आएगा? एक्सपीरियंस आएगा। ठीक, तो ये हमारा डिज़ाइन था आज का कॉम्प्रेशन मेंबर का। अगर आपको कुछ नहीं समझा है तो आप मुझसे पूछ सकते हैं, और अदरवाइज वी विल स्टॉप हियर। कोई क्वेश्चन है?
No, sir.